Hello, I'm Peter Vaughan, the Applications Director here at Power Integrations. I've been designing switching power supplies for the last 15 to 20 years. Switching power supplies have the reputation of being very complicated, large number of components, and then on top of that, with the ever-increasing energy efficiency requirements, the design challenge only becomes greater. Today I'll be showing you how Power Integrations' LinkSwitch-II power conversion IC can dramatically simplify your designs by removing up to a third of the components. It's ideal for adapters that require a constant voltage output, chargers that require both constant voltage and constant current, LED drivers that require constant current, or any application that requires a constant voltage or constant current output. Fewer components means simpler design, higher reliability, and greater energy efficiency. So if we take a look at this is typical of the components in a traditional power supply design. This is the AC input and high voltage side of the power supply. This is the transformer, and this is the low voltage DC output side. These components down here, their only purpose is to sense the output voltage and feed back an error signal to the primary side controller, which in turn maintains the output in regulation. Now if we swap this FET controller, which is a TinySwitch-III in this case, with a LinkSwitch-II, LinkSwitch-II is unique in that it uses a winding on the transformer to sense the output voltage and feed back to the primary side controller rather than requiring a separate circuit. The benefit of this approach is you dramatically simplify your design by eliminating the need for all these feedback components. One of the parts we've got rid of is the opto-isolator, which is expensive. We've also eliminated a number of other passives and transistors, all of which burn power and make the supply less efficient. We've gone from a complex design to a simple one. We've reduced the number of components by about 30%, increasing efficiency and increasing reliability. In order for LinkSwitch-II to provide the same output voltage accuracy as a design that has a feedback network, LinkSwitch-II only samples the voltage on the feedback winding when that voltage represents the actual output voltage. So let's see that in action. What I have here is the board from the LinkSwitch-II reference design kit. It's a 5 volt 1 amp design with an output voltage tolerance of plus or minus 5% and an output current tolerance of plus or minus 10%. Every design must meet the output specification over a wide range of operating conditions. That includes things like line voltage variation, load variation, component tolerance, and temperature. To demonstrate how robust and accurate LinkSwitch-II is, we're going to demonstrate each of those. So firstly, we're going to demonstrate the line voltage regulation performance of LinkSwitch-II. And to do that, we're going to vary the AC input voltage whilst monitoring the output voltage of the design. And ideally, we'd like to see as little change in the output voltage as possible. So as I increase the input voltage, that's shown on the meter on the left. As I get to 85 volts, which is the minimum for Japan, we can see the output voltage on the right is 5 volts. As I go through the US, to the minimum of Europe, which is 185 volts AC, the output's still 5. And then finally, as I go to 265, which is the worst case for Europe, we can see that the output voltage hasn't changed at all. We've actually been measuring the output voltage at the end of the cable, so LinkSwitch-II has not only been regulating the output voltage, but also has compensated for the approximate half a volt drop that appears across the output cable. So for the next test, I'm going to show how LinkSwitch-II regulates the output current, which is ideal for applications like battery chargers and LED drivers. So as the output current approaches 1 amp, the output voltage begins to fall, but the output current remains constant, which is critical for maintaining the charging current for battery chargers or consistent light output of LED drivers. In practice, the power conversion IC has to work with a wide range of component tolerances. The component tolerance that has the largest impact is the transformer, typically specified as plus or minus 10% at 20% range. For this test, we'll be replacing a 1 millihenry transformer for one with a 0.9 millihenry value. So let me reapply the AC to the board, and as we see, the output voltage is still 5 volts, and as I increase the output current, again we see that the voltage decreases, holding the current constant. So even with component tolerances, LinkSwitch-II comfortably meets the output specification. So for this last test, we're going to show how accurate LinkSwitch-II is with temperature. So what I have is a thermocouple monitoring the device junction temperature, which is displayed on this meter. So what I have here is a can of freeze spray, and other than being very effective for cooling yourself down on a hot summer's day, what I'm going to do with this is actually use it for the purpose it was intended, which is to cool down the LinkSwitch-II device. What we can see on the thermometer is we've reduced the temperature of the IC by approximately 50 degrees C, and during that change in temperature, the output voltage has not changed. One thing we haven't touched on so far is energy efficiency. Well, LinkSwitch-II doesn't just meet energy efficiency requirements, it exceeds them, both in terms of active mode efficiency and no-load input power. Worldwide energy efficiency standards have and will continue to tighten, but because we've eliminated up to 30% of the components, and importantly the lossy current sense resistor, LinkSwitch-II designs are significantly more energy efficient. So what we've seen here today is that LinkSwitch-II dramatically simplifies power supply design, as well as being very energy efficient. It's ideal for chargers, adapters, power supplies, and LED drivers, and importantly, it meets the output specification requirements with variations of line, load, component tolerance, and temperature. If you'd like to repeat the measurements I've made here, this board is available as part of the LinkSwitch-II reference design kit. For more information, see the URL at the end of this video, and thank you very much for watching.